In this lecture, we're going to continue our discussion about how chemistry influences our food and our cooking methods. We're specifically going to look at different cooking methods and how they work. Some of the methods we're going to touch on is boiling, pressure cooking, sous vide, microwaves, and then the no heat preparation. In the previous lecture, we talked about cooking an egg. When you're cooking an egg or something in a frying pan, you are directly transferring heat from the flame or your cooking element on your stove to the pan to the food. This happens in the oven also, which heat from the element of the oven heats up the air and cooks that food. Another way you can cook food is through boiling. And boiling uses the properties of water to help with the cooking. Water absorbs a lot of heat, and we talked about this when we talked about water in previous chapters. Before water is converted to a gas, it stores a lot of heat. It has a lot of latent heat. This is a result of the hydrogen bonds in that water. Since water can store a lot of heat, it's a great environment to cook in. So you can add the heat from your cooking element into your water. This creates the boiling environment, and all of that heat in that water then can be used to cook your food. One thing we do need to be aware of when you are boiling as your method of cooking is that the temperature in which water boils changes with altitude. So if you're living in a place that has high altitude, Colorado, for example, water is going to boil at a lower temperature. The pressure above that water is lower, which results in the water boiling at a lower temperature, so that water is not as hot. And as a result, if you look at a lot of recipes or cooking instructions, it's not very clear here, but it gives you some directions for high altitude. Oftentimes you have to increase the amount of time you cook a food in order for it to be fully cooked because that temperature is lower at a higher altitude. That relationship between boiling temperature and pressure also comes into play when you're looking at pressure cookers. Instant Pots are the rage currently. This is a pressure cooker. What is happening in a pressure cooker is you have water. You're heating up that water to the boiling point. Once it boils, you get that conversion of the water from the liquid to a gas. In a pressure cooker, that gas can't escape. So if you're boiling water on a stove, that gas escapes. You're not changing the pressure that you're cooking at. In a pressure cooker, that water vapor, that gas, increases inside the cooker. This increases the pressure. As you increase your pressure, your temperature in which your water boils increases. So the temperature of that water in the pressure cooker is much higher than the temperature that you can get water at if you're just boiling it on a stove. And as a result, a pressure cooker cooks materials a lot faster, cooks your food a lot faster than if you were just putting it into boiling water on a stove. Something else that you've seen an increase in recent years is the sous vide method. This is also a method in which water is used as your means of cooking, your transferring of heat. With this method, you typically have a piece of meat or whatever food you're cooking that you put into a vacuum sealed bag, and then you stick this into your water. The temperature at which you cook at using this method can vary, but the key here is that you are using water, so that water is transferring the heat uniformly to your item that you're cooking. The difference in this method compared to direct boiling is that your food is in this vacuum sealed container, so it doesn't directly contact the food. That direct contact of the water to the food will change the consistency of the food. So this is a way to use water to cook your food without having that water directly in contact with that food item. Another common way that we cook our food is through the microwave. Everything we've talked about so far, we have focused on water and heat. Heat is energy that has wavelengths in the IR range, which is most of the heat that we deal with on Earth is in this IR range. Microwaves use energy that is, or radiation that is in the microwave range. This is, if we think back to our discussions about wavelengths of energy, microwaves have longer wavelengths, less energy compared to radiation in the IR range that we typically associate with heat. So this is, microwaves are lower energy, so this doesn't have the energy to break the bonds. When we're talking about cooking food using previous methods, we are breaking those bonds from the energy source that we're putting in, from that heat. What happens in a microwave is that the microwaves come in and increase the movement of our molecules, specifically our water molecules. As you increase the movement of those water molecules, because they have more energy, they bump together. That friction that is caused from them rubbing together creates the heat, which then cooks our food item. One thing to note that in a microwave, the microwaves don't penetrate materials much more than an inch or inch and a half. That is why when you're cooking food in a microwave, it's often best to have smaller items. So cooking a big lasagna is not efficient because it's hard for those microwaves to penetrate into that lasagna. The last method of food prep that I want to discuss is our no heat preparation. So up until this point, we've used heat or microwaves, which create heat, to cook or change the chemistry of our food. Two different non-heat methods that we'll talk about is drying and curing. And both of these methods rely on the removal of water and the addition of substances such as salts to prevent the growth of microbes. An example of this is drying fruit. When we dry fruit, we're removing that water. Once you've removed that water, it changes the environment so harmful microbes can't grow. So when we convert grapes to raisins or we dry out apricots, we're removing that water environment, so therefore the microbes don't grow and it's preserving the food and we can eat it much longer. Obviously, a raisin stays fresh longer than a grape. Salting also changes the environment so microbes can't grow. Microbial organisms don't like high salt environments. So if we salt meat, we are removing some of the water, but we are also creating an environment in which those microbes don't grow, so those preserved meats can stay at room temperature for much longer. So that's an overview of some different cooking methods and how chemistry comes into play when we are dealing with cooking.